Welcome everyone to STG301. We're talking about data protection and resilience of AWS storage. By way of introduction, my name is Ken Hui. I'm a solutions architect here at AWS. Next month will actually be 5 years. And most recently, I've been focused on data protection. I'm helping our customers think through their strategy for data protection, including AWS backup. Palak?
Hello everyone, thank you for being here with us. I'm Palak Desai. I lead product management for AWS Backup. Glad to be here. All right, now we can get started. You guys can hear me okay? All right, awesome. So from an agenda standpoint, today we are going to talk about resiliency, why it's important. We'll talk through certain strategies on high availability and data protection. Then Ken has a wonderful demo for you all, and then we'll tee up the session. So let's get started. Now, we all know that data is growing, and many of you all are using data to inform your business decisions. Data is actually how many customers do their business today. And with the growing amount of data, it's extremely critical that that data is protected from any loss so that you can continue on with your business. Data has value, and as the data is growing, we also understand the importance of data protection. In this session, we are going to cover these strategies around data protection, how you think about it, like different architectural patterns that may help you in your environments, followed by a demo. Now, research has shown that not protecting your data or not being resilient resilient across failures has real financial and reputational impact. However, the good news is now we have many capabilities offered natively by AWS that you can leverage to ensure that your applications and your data is resilient. So let's start by defining what is resiliency. The ability for your workload to withstand any failure, partial or intermittent failure, across different components and eventually recover from that failure efficiently is known as data protection at a high level. But there are many pillars and many facets to data protection. So the first pillar for data protection is high availability. Say, for example, you had a component failure within your application, a network failure. So the ability to fail over in such situations so that your application is up and running is known as high availability. Let's take a real life example. If I'm on a video call, say Chime or Zoom, and suddenly the internet has a bad day, right? There are so many people trying to get to Zoom. It's having some sort of an outage within your environment. What you will see is that the application will deteriorate an experience. So video may not be that clear, your voice may be choppy, but your application will carry on. That is known as high availability. On the flip side is data protection, which is when the application is totally down and you need to recover from that failure, which is where concepts of data protection come into play. Now, there are many causes for failures. The most common causes for failures are some fat fingering. I'm trying to configure something, I add an extra zero or extra parameter, and as a result, it's caused some failures. There could also be load onto the system that can result into failure. Think of your Black Friday, right? You are all shopping and you see your e-commerce website going down. It's quite common. You have so many of those failures. There could be load, there could be human error. Those are the typical types of failures that you most commonly see. And for that, you may want to think through high availability. How can you fail over when a component fails and ensure that your application is still up and running? On the other extreme side are regional outages, acts of God, right? So for example, there's a hurricane and that region is down, or an earthquake and that region is down, right? For those kind of scenarios, you want to think through the concepts of disaster recovery or data protection. And how do you think about your applications from a viewpoint of those two concepts really depends on the criticality of your applications. If it's a financial application or a ticketing application, you want to design for both high availability and data protection at the same time, because you really do not want that application to go down. At the same time, if it does go down, you want to be able to efficiently recover in case of such failures. Now, at AWS, we have a shared responsibility model. The customer is responsible for resiliency in the cloud, and AWS is responsible for resiliency of the cloud. What does that really actually mean? So AWS has a bunch of infrastructures that we host, that we manage, so that customers can run applications on it. So from that perspective, AWS is responsible for the high availability of its regions, the availability zones and edge locations, all of AWS's global infrastructure, so that the compute, storage, database, and networking is highly available and redundant, and any other hardware services that we are running.
Yeah, and Paul, just to highlight that a little bit, an example of this is take S3. So we're AWS responsible to make sure that S3 is 11 nines durable, right? I think almost everyone here knows that. But what we're making sure happens is that whatever the state of this object is, when it's saved into the bucket, it's maintained and doesn't get they don't lose that object across all the EZs in that region. But the data itself is still your responsibility as a customer to protect. So one of the things I tell customers is, if you do something inadvertently to corrupt your S3 data, we will make that corruption 11 nines durable as well. What we don't do is create a backup automatically of your data in S3. So that is still your responsibility to do.
Phenomenal. That's a great example. So this is a great example of how customers are responsible for resiliency and of their applications, right? So you're responsible for, like Ken mentioned, taking backups of applications. You're responsible for ensuring that you have the right access privileges and permissions in place, so that there is no inadvertent actions being taken as a result of loose access controls. So this access security policies, the way you think through your disaster recovery scenarios, your cyber resiliency, securing the applications that run on top of the infrastructure, making them resilient, is something that we look to you to take care of. But we provide enough hooks and constructs that allows you to make your applications running on AWS resilient. Now, from a portfolio standpoint, we have a wide variety of services. We cover the storage portfolio from a viewpoint of block with EBS, object with Amazon S3 and Amazon S3 Glacier, and filers with Amazon FSx, Amazon EFS, and Amazon File Cache. And each of this storage system has a variety of mechanisms through which you can make sure that your application is resilient. You can look through AWS Backup as that consistent mechanism to back up your data, application data, so that you can protect it. You also have object-locked S3 versioning and variety of capabilities such as disaster recovery that are made available to you, that you can use to make sure that your applications are resilient. And Ken, in the later part of this session, will walk you through certain custom architectures that have been successful in customer environments, if you will, reference architectures that have been successful in customer environments to actually achieve data resiliency and protection. With this backdrop, I would invite Ken to walk us through the high availability strategies.
Thanks, Palak. So let's start with the basics a little bit. So this should be some the diagram's familiar to you, but I want to talk first for a few minutes about regions and availability zones and how they play into maintaining high availability within AWS. So for those, just to recap, a region is essentially a geographical location where AWS has data centers. And the idea here is we want to make sure that customers all over the globe has ready and quick access to some compute resource, some type of resources within AWS. It also, the regions also allow you to set up disaster recovery from region to region if you need. And thirdly, it satisfies the requirements that some of our customers have, that they need to keep data within a certain location. So for example, one of the rules that we follow at AWS is if you store your data in a certain region, we will never move that data out to another region unless you decide to do it yourself. So within each region is a whole series of physical data centers. What we do in a region is we actually take some of those physical data centers and we group them together in a logical data center called an availability zone. So an availability zone is actually not a single location. It is multiple physical equipment across multiple locations that are grouped together. What an availability zone is you can think of it as a failure domain. So each availability zone in a region is located far enough away that they are not in the same power grid, they're not in the same natural disaster zone or same earthquake zone, but they are close enough that you can do replication between availability zones within a region, synchronous. So this comes into play, for example, later when we talk about HA, if you want to be able to replicate data from one AZ to another AZ, synchronously you are able to do that. And this also allows you to survive the failure of any single availability zone. The other availability zones will not be impacted. So see here, as I mentioned, each data center and each AZ has redundant power, networking, connectivity, all separated together, again, to provide you that level of redundancy and just let you set up high availability. So different services in AWS has different types of resilience within their regions. So in the case of certain services, they are what we call zonal services. So they are services that are or the data is housed in a single region in a single zone. So for example, with EBS, when you create an EBS volume, you tell it what availability zone you want it to be housed in, or you can have us do it for you. But that EBS volume is not accessible to any availability zone but the one that it's home to. And then there's some regional services like S3, for example, where your data in S3 is stored across multiple AZs within a region, so that if one availability zone goes out, you are still able to access your data in S3. And finally, there are global services, right? These are things like IAM, for example, where it is not really, you don't have an IAM only for US West 1 and a different IAM for US East 1. Right? It's one single service that spans multiple regions. So this is important because it helps you think through, as you're looking at using AWS storage services, depending on whether it's a zonal service or regional service, that will help you determine what type of HA strategy you need to enable. So thinking about the design aspects of this, so in a traditional enterprise, right, you probably have one data center. In many cases, you have your applications in one or two racks. And so your failure domain is potentially that one rack or that one data center. And then you may think about having another data center in order to set up a second HA pair. With AWS, though, depending on the service, you may have different ways that you can set up resiliency. I mentioned the idea of having multi-zonal resilience. And I'll give you an example of this later, but for example, an EC2 instance or an EBS volume is located within a single zone, but there are ways that using various AWS features, you can set up an HA pair in a second zone, so that when there's a failure in one zone, you can pick up in the other zone. There's also the concept of multi-zonal recovery, which means that you may have a resource that is, again, like EBS, that if you need to recover the data, you can have your backups, for example, or the snapshots within that region, and you can recover into that zone. And finally, and then secondly, there's something called multi-region recovery, which we'll talk about particularly in the context of backup and disaster recovery, where you may want to have your data not in one zone, but actually across multiple zones, so that if there's any kind of an issue in one zone, you can either fail over or recover from that second zone. And that's the multi-region resiliency. So there are companies like Netflix, for example, or even Amazon Prime, where they run active across multiple regions. But if any one region fails for any reason, all users from across all the regions can be directed to one single region and still be able to run properly. So this is kind of a high-level concept. I want to talk through a very simple architecture that illustrates that kind of the different HA and resiliency characteristics. So That's starting with, I think, sorry, let me go back. Okay, yep, okay. So this is a pretty simple architecture. It is a zone with multiple AZs, and applications is running across those multiple AZs. So you have services like a NAT gateway or load balancer that can effectively redirect traffic from one zone to another. So it is a best practice, for example, that if you're running web services, that instead of exposing the web services directly, you basically put them behind a load balancer, not only because you want to be able to balance performance, but because you have the ability then to redirect traffic from one AZ to another AZ as needed. And to make that work in that second compute layer, there is the concept of EC2 auto-scaling groups. So you can't do auto-scaling within a single zone, but actually our best practice is you should do auto-scaling across multiple AZs in a single zone. So that, again, if you have some kind of an outage, some kind of issue in one of the availability zones, again, the load balancer will just redirect traffic as you spin up additional resources in those other AZs. And then at the database layer, with RDS, for example, or Aurora, you are able to set up standby copies from one AZ to another, so that if a database outage happens in zone A, we will automatically fail you over to zone B, the database. Or you can set up the concept of re-replicas, so that you can have actually multiple copies of that same database across multiple AZs, and then direct retraffic, so that you're kind of increasing your resiliency across multiple AZs in that zone. So that's just a quick example. What we actually want to focus the bulk of our time today is actually around data protection strategies and how that can help you with achieving resiliency. So Park, do you want to talk through that a little bit?
Absolutely. So when you think about data protection, the first thing that you want to think about are two key terms. One is the RPO, which is known as Recovery Point Objective. It essentially informs the amount of loss that your application and your business can withstand. That's your recovery point objective. The second term is the recovery time objective, which basically tells you how quickly, in case of a disaster, you need to recover. Again, these two terms will inform the business viability in case of any disaster that may happen. Typically, we apply a 3-2-1-1-0 data protection approach. I know it's a mouthful, but let's walk through it. You always want to have 3 copies of your data, independent of your primary resource. 2 of those copies need to be in remote locations, so it could be a cross-account copy, cross-region copy. 1 of that copy should be in your primary account, and this is to reduce your RTO. We talked about recovery time objective. To reduce your RTO, you should have a copy in your primary account, so if you need to recover, you can recover quickly. You're not facing latencies because of the cross-region copies. 1 of the copies should always be immutable. It should be an isolated vault. We'll talk about what isolated vaults are. So that if there is a ransomware incident, you can recover safely from that particular copy. So it should be immutable as your last resort for recovery. And you should keep on testing on an ongoing basis. So there should be 0 issues that should be found in at least 1 of those copies for a recovery situation.
Nacha, I'll share a quick story. So I was working at a bank. I won't tell you which bank it is. But they had an outage situation where the entire data center went down in one fell swoop. This was in New York. You can probably guess what incident was that happened. And they had set up replication to another data center. Unfortunately, the data center was 2 blocks away, so that also went down. So they were resorted to having to go to their backup copies. Well, it turned out the way that the consultant had set up their backups, as they were doing their restores, they realized because they were using incremental forevers, it would take them 30 days to restore any server in their environment. And the reason they didn't know that was because they had never tested a restore process before until they actually had to do it after the disaster. So it just points out the importance that you should regularly be doing restore drills to make sure that that you're able to restore in the time that you're committing to your business, and that the data is that you restore is a known good source.
This is a great example for testing your processes, right? So you want to make sure that your data is secure, it's protected, but at the same time you want to plan for that worst case scenario so that you can recover efficiently. Now, this slide basically mimics the previous slide in terms of where the copies need to be. So one local copy for quick recovery, for your quick RTO. Your remote copies could be cross-region, cross-account copies, and there are a variety of technologies that you can use here for your secondary remote copies. It could be a replication-based copy, or it could be a backup that you copy over, and there are different use cases for that. And the third copy should always be for cyber recovery. It should be immutable, it should be secure, it should be isolated, and it should be tested on an ongoing basis so that you can recover efficiently from it. Now let's dive deep into when would you think about a backup? So backup is typically used for compliance reasons, for recovery against a ransomware environment, for data protection in general, but the guarding principle is recovery time objective. So for applications that do not need instantaneous recovery, can withstand a duration of time while the bits get recovered, for those applications, backup is a great way of doing data protection. You can create tamper-proof immutable backups using backup and restore technologies out there. Let's take an example, right? So you have your primary resources running in an account, everything is working fine, and there is a man-made corruption in that there's fat fingering, some configuration went wrong, and the resource was wiped out. At that point in time, great to have backups within your primary account so that now you can quickly restore and get back to a clean working copy of your data. But say, for example, because of unforeseen reasons, like Ken mentioned, things happen, the entire account is down, it's compromised, maybe it's a regional outage. At that point in time, a backup copy in a cross-region or cross-account environment is great, because now you have a secondary location which is far away from your affected location where you can have that data and you can recover from it safely.
Yeah, what we find is that more than 70% of local restores happen with data that is kept, that is 30 or 60 days since creation. So what we have a lot of customers do is, as a best practice, is they'll keep a shorter retention period for their local backups. But because of ransomware, for example, they will maintain a longer a copy of their backup typically in a separate account for a longer period of time. And we really think of the account as the failure domain to think about. Because regional failures are very rare, if ever, but it is quite possible that an account can get compromised. So for us, that is the thing that you should be most concerned about, and the thing you should really focus on if at all possible is how do I, for a cyber security use case, is how do I get my copies of my data to another different account that is isolated from the workload account.
So while we're on the topic of backups, at AWS, we have AWS Backup as a consistent platform that can provide policy-based backup management across your set of resources and set of services offered by AWS, including hybrid workloads. Now, I do want to say that this is not the only mechanism of doing backups. For certain resources, there are native backup capabilities that you can avail to. However, AWS Backup provides a consistent platform and a policy-driven approach across your compute, your storage, your file systems, your object store, your data transfer technologies, your databases, and your applications, including hybrid applications through the support of VMware and SAP HANA. Not only that, using AWS Backup, you can provide immutability to your backups, you can provide policy-based retention mechanisms and locking mechanisms to your backups. More so, you can also do restore testing on an ongoing basis and provide reports which are auditor ready so that you can prove to your regulators that you are indeed resilient from an application standpoint. But
Okay.
Backup is not the only mechanism through which you go ahead and protect data, so we'll now talk about replication. Ken?
Yeah, so as Park mentioned, backups are great for getting a point-in-time copy that, that you want to restore that maybe you don't, it's not time sensitive in terms of RPO. So for example, maybe you're doing a daily backup, right? And you have need to recover the next day. So you may have possibly lost data for up to 20 some odd hours. But if you have an application that requires as close to zero in terms of RPO and RTO, then replication is a general IT approach that's been in the industry for a long time that basically allows you to say anything that's written on the production side will almost immediately get written to the target side so that you're able to spin up a new environment when necessary, and you're only potentially losing a few minutes of data, or in some cases you don't have any data loss whatsoever, depending on the tool that you're using. So it's typically not used for every single application because, as you can imagine, there's a cost involved in having that type of, having replication and being able to maintain that type of low RTO, RPO. So I'm sure if you ask your business owners or your managers how much data they can afford to lose, they'll say zero, right? And you ask them how much time can I afford to be down, they'll say not at all. And then you tell them how much it costs, and they'll typically say, well, okay, we can accept X. So one of the things when we think through replication and we think about backup is before you decide what tool to use, first, you need to classify your applications. So a very simple model, for example, is to have something set up these tiers. You can call them, gold, silver, platinum, gold, silver, or whatever you want to call it. And the idea is for each of those tiers, we recommend attaching an RPO and an RTO. And then you want to take all the applications that you are being asked to protect and slot them into those particular tiers. So that you are creating the right data protection architecture for the right application criticality. Because again, the more critical the application, the more likely that you want a low RTO and RPO, but it also probably means it's going to be the highest cost. So some examples of services that we have that do replication. We talked, S3 has what we call cross-region replication, which can also be done across account. So in the case of S3 replication, there's two modes. One is you will drop, when you make a change in one bucket, we will replicate that bucket to the object to another bucket in a different region and or account, and we'll do that on a best effort basis. There's also a feature you can turn on called time control, where you can define an SLA that says within 15 minutes, I need to the target bucket cannot be behind for longer than that amount of time. And then what will happen is the S3 service will prioritize making sure that any changes in the source gets over to the target within that 15-minute SLA. And then because we can do backups in S3, you also have the option of being able to copy that backup to another account or into another region, and then making that backup immutable so that in the case of a complete malware attack, you are able to recover quickly from the backups. And then, is anyone here using FSX for ONTAP? Okay, a few of you. So you've already realized FSX ONTAP has a number of data protection features natively, including the ability to not only create snapshots and backups, but also to replicate those snapshots to another FSX instance in another region. So that's something we also recommend for customers of FSX or ONTAP if they have that level of criticality. And then EFS is our Elastic File Service system, and it also has built-in capability not only to do backups, but also to replicate to a second file system in a different region or account. All right, so this is an example of what a DR architecture might look like using replication. So in this example, we're using something called AWS Elastic Disaster Recovery. So with this service, what happens is on the source side, which actually in this case can be an on-prem environment, as well as in a AWS region, we basically have an agent that's running on all the servers, or EC2 instances in the case of AWS. And these agents are really filter drivers that splits writes that are made to the underlying storage. So the storage will get written on the source side, and then that write will be replicated to another region within AWS or to where it gets stored. So the replication itself is going to be continuous. It's really semi-synchronous. So we'll batch it up, and as time goes on, we'll continue updating the target side. And then that data is stored on these EBS volumes that is in a DR region within AWS. And then in the case of a disaster, DRS will actually be able to launch brand new EC2 instances using that replicated data. So that's a great way, again, if you have a disaster either on-prem or in your source region and you cannot tolerate having more than a few minutes of loss, DRS will make sure that you're able to spin up quickly. And in the case of on-prem, for example, if you're using VMware, DRS has the ability to convert those VMware instances into EC2 instances within AWS. Okay, I'm going to go through a couple of architectures and then a demo of one of those architectures. So let's talk about S3 first. How many of you are using S3? Okay. How many do you have S3 versioning enabled? Okay, a few of you. How many are using replication with S3? Okay, a few more. How many of you are backing up S3? Okay, good. Okay, so as I expected, smaller number. So right now, actually, our statistics tell us that most customers do not use versioning, and then even a lower number of customers are actually replicating their data in S3. So I'm going to talk about why that's. I know I already talked about why that's important, that you do have some kind of data protection. So again, some of our customers are under the false impression that since S3 is 11 nines durable, that means that we have an automated backup of the S3 bucket, and that is not the case. In fact, I was talking to one of our S3 PMs, and they actually had to write a script for our support people, explaining why when you delete data in S3, we make sure that deletion is 11 nines durable. So even if it's an accidental deletion. So let's talk about how using that 3211 principle that Palak talked about, let's talk through an architecture that would be able to protect your most critical data within S3. So in this case, we have an S3 bucket in a workload account in a particular region. The versioning is kind of the base, but versioning itself is not really a backup, right? Because one of the principles of backup is it cannot be dependent on the source. So with versioning, if something happens to your bucket, then all the versions are inaccessible. So versioning is a great way to recover very quickly operationally, but it won't guard against, again, the entire bucket being deleted or being corrupted. So that's where the backups come in. So there are tools such as AWS Backup that will create a point-in-time copy of your bucket and store it in a different location within that account, so that if you need to, you can recover data quickly from that, and we call that a AWS Backup Vault. So that's your first copy, what we talked about. Remember, we said that for your most critical data, we actually recommend having 3 what we call recovery copies. So your first copy is going to be this local copy that's both a combination of versioning as well as a backup. Our second copy, in this case, we're going to talk about is something that's going to be stored in a second account that is primarily used for a cyber resilience use case. For example, if your primary account has been compromised in some way, and you can't even get to the local backups, maybe because or maybe you have a ransomware attack, and they've now gotten access to even the local vault. So in this case, we actually allow you to set up if you're backing up S3, we allow you to create a second copy and then replicate that copy to another account or region. And again, we recommend you at least do another account, because that is where you're most likely to be vulnerable, if you're vulnerable at all. And then in that second recovery account, we recommend customers use something we call the logically air-gapped vault. Paul, do you want to talk a bit about that?
Absolutely. So in August, we GA'd a functionality which is known as logically air-gapped vaults. Remember, we talked about the fact that you need an isolated copy so that if your accounts are compromised, and typically because of ransomware, you need to make sure that there is at least one immutable copy that you can recover safely from. This is where a logically air-gapped vault helps. It provides you with isolation, so it is something that's managed by the service. It's a service-managed vault in a service-managed account using service-managed encryption, so that now you can imagine a situation in case where your primary accounts are compromised, so that you don't have access to your keys, or your primary resources are encrypted, or your backups are encrypted. At that point in time, you can default into this logically air-gapped vault from which you can recover, because now it is isolated and it's managed by the service with service-owned encryption. Moreover, there is also a nice partner logo, which is known as Elastio. We also recommend that customers use some sort of malware scanning on an ongoing basis, so that you can have that one copy which is which is absolutely clean, that you can recover from in case of any disaster. And like Ken mentioned, you do always want to test on an ongoing basis, so that there could be restore testing as well that you can implement within your cyber vaulting strategy, so that you are ensured that at least there's one copy that is recoverable.
Okay. Thanks, Pollock. And then what I want to talk about is the third copy, which is the primary use case for that is really disaster recovery. For critical data where you require very low RPO and RTO. So again, backups is a great way, both locally as well as a copy in a cyber vault. But in a situation where a disaster happens and you need to be back up and running, my mantra that I tell customers is the fastest restore is not to have to do a restore at all, right? It's to actually have the data already sitting in the location where you want to fail over. So in this case, what we're using is a combination of S3 replication with time control, which I talked about earlier. So this ensures that if your source bucket is going to have a replicated copy in a different region and account within the SLA that you define. And then we also are going to leverage something called S3 multi-region access point. It's a very long name to basically say it is essentially a virtual endpoint that you can layer on top of your S3 buckets. So in this case, the way you're going to configure your applications is they don't actually talk. They're actually going to access the multi-region access point, that virtual access point, to get to your source buckets. So that and then when in a disaster, when you fail over, you essentially will move that access point to your failover bucket, so that they can be up and running very quickly. So this is again particularly great use case when you need to fail over quickly. Sorry. One thing to keep in mind is this works. This works best when the assumption is that what you're fail over to is the latest version of your bucket, right? So one of the things one of the questions I often get from customers is, could I use replication as my backup, right? And my answer actually quite simply is no, because that's not what it's suited for. And I'll give you a very good example of why that's the case. So if I'm replicating, and again, replication, the idea is we're always going to replicate the latest copies. We'll also replicate all the versions, right? So the idea is, hey, maybe I can go back to a previous version. The challenge with that, if you want to do that, is if you're doing it for a few objects, not too hard. But what if you had a million objects in your bucket, and you say, hey, because of ransomware, I want to recover to my bucket the way it looked 5 days ago. Okay. To do that using replication, you would have to know for 5 days ago what version of every single object represented that bucket 5 days ago. And then you would have to tell you would have to have a function that goes to S3 and goes, I want to recover the version, that particular version across all 1 million or more objects. And since there's no concept of checkpointing within replication, there's no way to actually do that today without you essentially having to build a database catalog yourself to track those changes, and then build software to expose the versions that you want. So what I tell customers, if you are able to do that yourself, congratulations, you created AWS Backup, and now you're the product team. So again, very important that as you think about your data protection strategy for S3, replication is great for failover to the latest copy, but backup is what you want to use if you're trying to recover from a specific point in time, because that's what backup actually does. Okay, next I want to talk about EC2 EBS, and then I'm going to actually do a demo of the architecture. So hopefully today, how many are using EBS, EC2? Okay, good number. All right, so obviously the way to protect EBS today is to use snapshots. So AWS Backup, for example, and other applications that do backups will integrate with EBS snapshots natively to create a copy of your snapshot within the same region. Just to be clear, EBS snapshots, the name is a little bit of a misnomer because snapshots typically, traditionally have been like a virtual copy of the source system. In this case, all your EBS snapshots are actually stored in S3. So it's not actually, and it's a full image copy. Even though we're doing incremental forevers, the way we're architected EBS snapshots lets you be able to always be able to recover a full EBS volume at whatever snapshot point in time you want. So that's the first copy, the local copy. Similar to S3, you can create a backup copy. We recommend you then send that backup copy to a second account if you're using AWS Backup, into our logically air-gapped vault, so that you are able to recover from that if something happens on your source side. And again, one of the capabilities of logically air-gapped vault or lag vault that is very important is that we have the ability to share that vault with different accounts. So imagine a scenario where your workload account has been compromised, and you either don't trust it, or perhaps your security team goes, hey, you can't use that anymore. It's now a forensics account, or we have to, for insurance purposes, we need to keep that around isolated. So in that case, what you can do with lag vault is you can share that, you can create a brand new account, right? So that you can trust that it hasn't been compromised because it's new, and you can share that vault with that brand new account, and then do a direct restore into that account. And as we talked about, using something like Elastio, you're able to scan your backups to make sure that what you're restoring is actually a clean copy. So that's your cyber recovery copy. And then the third copy is the DR copy we talked about. So as I mentioned, most backups with EBS tend to be daily backups. You can do them more frequently, but in general, the nature of snapshots, you're probably doing it maybe at an hour, maybe in between. And there's a cost involved with that, obviously. With something like DR, Elastic Disaster Recovery, which I talked about earlier, we're doing semi-synchronous replication to another region so that you're only a few minutes behind, and then you can launch, at any point you can declare a disaster, do a failover, and we'll launch a brand new instances using the data that is stored within that DR region. And then you can actually also fail back if you want at some point, or fail back or fail over to a new account that becomes your new source. So that's the kind of the recommended architecture if you wanted to be able to do both local recovery, cyber recovery, and DR. What I want to do next is going to walk through this demo, and specifically I'm going to walk through EC2 EBS and how you can protect that using both AWS Backup and also to get your local copy, your cyber recovery copy, and then DRS for your DR copy. So, all right, so here in this account, you can see I have two servers, doc server 1 and doc server 2. They're both servers actually have two volumes attached. Let's see. Should go forward. Yep. Okay. So, so yeah, if you go to the volumes, you'll see that there are. I've labeled these. So you're going to have each instance has two volumes, a root volume and then what we call a doc repository volume. And that volume is going to hold, in this example, some type of user data. These are Windows servers, and what you can see here is that in the D drive, which is one of the volumes, I have a couple of folders. One is for marketing, which will have some marketing videos that the marketing team created. And then there's a publishing folder, which has like music reviews or video reviews. All right, so what I'm doing here is I am actually going to go ahead and detach the document volume on doc server 2. So I'm going to do a force detach to simulate a failure. And then on top of that, I'm going to go ahead and probably delete the volume. Oh. Okay, I'll say with that. So while the detach takes a couple of minutes, so while we're doing that, we're going to go ahead to the AWS Backup Console, and you see that I have multiple local vaults in this account. I am going to go to a vault called local vault, and you'll see here I have different recovery points. So these are your backups, and I have different recovery points for obviously the servers, the root, and the root volumes, as well as the doc repository volume. Okay, so now that the doc repository volume has been detached, I am going to go ahead and delete the volume. Okay, so now I've lost the volume. And then if I go over to my remote desktop and open up the folder, you'll see that my D drive is gone. So all my documents are gone. All the data is lost. So what I'm going to do now is go back to my AWS Backup Console, and I'm just going to initiate a restore. And I'll pick kind of the latest, one of the most recent copies of doc repository 2. Again, we might say the zone service, you have to pick in the relay zone for that volume. And I'm going to initiate a restore. It'll take a few minutes because it's got to actually find the snapshot and then instantiate. What it's going to do is instantiate a new volume using the data that's in that snapshot. Let's see. Just take a minute. Okay, and you see here that now I have the doc repository volume 2 available again. And then I just need to go ahead and do an attach to doc server 2. And now I'm back in business. And if I go back to my remote desktop, you'll see the D drive is back as though it was never gone. All right, so that's kind of the local recovery copy that I talked about. But now we're going to talk about what happens if your account was compromised and you actually lose an entire instance, and you also don't have access to that local copy. Excuse me. So, let's see. Yeah, I'm going to go to doc server 1. I'm actually going to simulate a failure by stopping the instance, or actually terminating it. So at this point, it's going to shut down, and now the entire instance is no longer accessible. So next, I'm going to go back to my console. AWS Backup Console, sorry. And I'm going to my vault. So in this case, we're going to assume for the purposes of this demo that the local vault is actually not accessible to us. So I'm going to go to this vault that's shared called Lag Vault 1 that has been shared with this account. Again, it can be shared with any other account that you decide to share it with. And you can see here that that lag vault belongs to an account that starts with 30. It's a different account that is where your local EC2 instance is running. So I think I went ahead and initiated a okay. So now I'm going to go into the lag vault, and you see that I have a bunch of recovery points. These recovery points were created on the source side, but then copied over to the lag vault in the second account. And I'm going to go ahead and initiate a restore. So again, I'm going to fill out some. I can choose to essentially duplicate the specs for the volume that was deleted, the server that was deleted, or I can actually create a new updated specs. I'm going to go ahead and do the restore of the entire instance. It takes a minute or so to kind of get the restart going. And right now what it's going to do is actually going to recreate the AMI as well as the EBS volume, and it's going to pull it from the recovery vault in that second account into the VPC in this source account. Should take about a minute. So while, as I mentioned before, you can actually, for this exercise again, I happen to be sharing it back to that local account, but in practice you'll probably want to use a brand new account for this. But you can see here very quickly doc server 2 now back up and running. So I've got that restored. All right, let's see. So next I'm going to talk about DRS. So in this account, I have two servers that make up my application, a DB server and a web server. Make sure it's playing. Yep. Okay. And that server lives in, I believe, US West 1 in California. Note the instance ID because I'm going to show you that is being replicated to using DRS. So in this case, in the DRS console, I'm actually looking at US West 2. That's our DR region. And you can see that I've already started the replication and that it is in a ready state for recovery. The instance IDs will be the way you can tell that what the source servers were. Okay. Now I'm going to go back, and what I'm going to do is simulate a failure on my source region. Okay, at that point, we're shut down. It's probably take a minute. All right. Meanwhile, on the target side, what will happen once DRS detects that the source servers are no longer replicating? We'll go back and you can tell this is actually telling you how far behind you are because it's been down for a minute or so. But it tells you that we're ready for recovery. So at that point, I can choose the servers I want to do a failover on. I will go over here and do a failover. And one of the things to note here is that what DRS does is actually does snapshots. So checkpoints of your EC2 instances. So you can actually choose to go back in time to go back to a previous copy of your servers. So I'm going to pick a particular time. Let's see. I'll initiate a recovery. And you can see up there a new recovery job has been created. If I draw into the details, it's now actually going through the process, and you can see what we're doing here is we take a snapshot of the most recent version that's available, and then we actually go through a conversion process to get it ready. So, for example, if this was a VMware instance that you were replicating, that conversion process will actually do that, convert into EC2. So I kind of spread forward, and you can see here that we've now launched the recovery instances successfully. And in the recovery instances tab, you see now that we have the 2 new instances that are now running in US West 2 instead of US West 1. If I go back to US West 1, this instance is still stopped. If I switch over to US West 2, you see that I have those recovered instances running. So I believe that is the rest of the demo. Yep, okay. All right, so that's the demo. Let me come quick takeaway. So as I mentioned earlier, really do the job of classifying your workloads. You don't want to apply a single strategy across everything because that probably is not appropriate. Make sure you're working with your account team. I mentioned before that most customers, for example, aren't even using versioning on the S3 buckets. So work with your account team. They can help you analyze your current environment and let you know what's protected and what's not. Again, all the AWS services have multiple capabilities around HA and data protection. And then, as I mentioned, maintain multiple copies. That's your best way, really, to guard against failure, is to have multiple copies stored in different places. And I'll talk about...
Right. Yes, so this concludes our sessions, but we have had many great sessions throughout the week. If you haven't caught them, few of them are recorded and are live on YouTube. So all of our breakout sessions are recorded and they're live now. So you could go in and look at what's new with AWS Backup, some of the ransomware strategies that we talked about in STG301, and of course this session is also present and is being recorded. They'll let you guys take a picture so that you can go ahead and take a look.
Yeah, the way you'll get to them is in YouTube, it'll be the AWS events channel, not the AWS channel. But in the AWS events channel, you'll see, some point probably next week, you'll see a playlist for reInvent 2024. And then within there, they'll group all the sessions according to category, and you can then browse all the breakout sessions.
Perfect. Well, we thank you for your time that you spent with us today. I know you are all getting ready for replay and all the other events in the evening, but please take a moment to give us a thumbs up on the survey, give us feedback so that we can be here next year again with you all talking about...
And to improve it.
Yeah, to improve our session so that we can be here again next year with new things that you want to hear from us, talking about resiliency for your application.